Okay, good morning everyone here in Montreal, and good day everyone else in the world seeing this session. Today we have scheduled, this morning we have scheduled 1.5 hours to talk about one single project, so we really have the time to dive deep into this project called S1 Eindhoven. We've prepared a lot of live demos, a lot of showing just how we work actually on our own laptop, so we will switch between our presentation and between the software we use actually into this project, and there will be plenty of time afterwards to ask questions because we do not plan to talk about it for 1.5 hours. So before we introduce ourselves, this will be a very practical presentation with a lot of live demos as mentioned. And what's really exciting about this project is that all the BIM data we show you today will be published right after this session officially, so that it can be used by students, by practitioners, by software developers, actually as a demo data set, which represents the current state actually of how we use BIM in the Netherlands. So my name is Stijn from Schaijk. I'm here with my colleague Niek Rooijackers. We've actually worked last 7 years close together in implementing BIM at Volker Wessels, more specifically at Stam and Coding, which is one of the companies which we will elaborate on in a few minutes. We've been working for 7 years closely on implementing BIM, and for us this is really a moment where we can actually show what we did in the last 7 years, which all come together actually in one specific project. So that's for us really really cool to stand here actually. So we invested 7 years of our time to train a lot of people within our company to actually make this data set. So I really want to start with this. We did not make the data set ourselves as BIM managers. So our role as a BIM manager is to train and guide the actual people in the projects so they can make the BIM models themselves. All the models, all the data, all the samples you will see today are not made by BIM specialists, but are made by people in the field. So within our company, it's also very important that the people in the field, just the project managers, the superintendents, the project engineers, they use BIM in their work, and they do not have a specific BIM role, but BIM is part of their work. So first we worked, actually you can see that we worked 7 years on this project, not directly, but indirectly. And from that perspective, I think that also buildingSMART and the buildingSMART community has actually worked on this project for maybe more than 20, 30 years. So it's also a bit of a buildingSMART achievement that those projects can be done in this way. So a little bit more about Volker Wessels. We are an enterprise company, have around 16,000 colleagues based in the Netherlands, Germany, UK, and Canada, divided over several divisions actually. So we make infrastructure, telecoms, but we are part of the construction and real estate division of Volker Wessels. Within our construction and real estate division, we have around 35 subsidiaries or sub-companies, which all have their own specialism and all have their own part in the process of a building life cycle. So combining all those companies, working together with all those companies, we can be part of a full building life cycle. All those parties have their own identity, as you can see in the logos. All have their own culture, all have their own specialism. And actually these are still the old logos because we have some rebranding in our enterprise. So you will see some new logos in a few seconds actually. So Niek and I work at this moment for those companies. So Stam and Coding, which Niek will elaborate on in a few minutes. And I myself am a process manager at Digibase. And Digibase is a company which actually helps all the other companies in the digital transformation and training and guiding them. Often people think that we are a centralized knowledge organ within Volker Wessels, but that's not. We are a centralized knowledge spreading company. So what we do, we know what's happening in all those other companies, and all the smart things where we think which are happening in those companies, we make them scalable. So as an enterprise company, we take all the good ideas of all those people working in the field, and if we think it's a great idea, we take it and we make it scalable. Because what we actually saw, we are now, I think, around 10, 12 years of active BIM implementation at Volker Wessels. And after a few years of doing that, we saw that we only reached 20% of the people of our company. So the people who are actually can be identified as the digital pioneers, the people who were adopting BIM workflows themselves. So 4 years ago, we started Digibase with the purpose of actually trying to include all the other people of our company in the virtual construction process as well. So in a lot of use cases you will see today, it's really about the people-centric, the very simple use cases, very simple workflows we actually try to focus on with Digibase. We do that in a few ways. The most important part is the upper part actually where we do the business support, project support, so we give a lot of in-company trainings, training sessions at our office, but especially also outside our office in the field. We guide all our employees in making better use of actually our digital data and digital models. We also have a small business and development team, and we have a great office where actually everyone can come together to share their experience and share knowledge with our other colleagues. So that's about Digibase. Niek will elaborate a bit more about Stammen.
Yes, thank you, Stijn. As Stijn already mentioned, Stammen is also one of the sub-companies of Volker Wessels. And in contrary to Digibase, we do really build something. So we really create buildings. We're a main contractor. So we're a building company. We exist since 1987, and since 1999 we're part of the Volker Wessels family. Located in Eindhoven, the south of the Netherlands, for people who don't know where Eindhoven is. We work with approximately 150 colleagues on 120 million euros of turnover. And that turnover is mainly done in the high-rise buildings. And when you're in Montreal, I don't know, we don't build things like there and here, but for the Netherlands we build high-rise buildings. So they're between 50 and 100 meters high buildings. So that's what we do mainly. That's our specialism. And also some turnover comes from houses, just residential houses. Some repurposing projects from small to big. Utility construction and some parking garages. So that's mainly what we do. I've got some things to show you, some projects, so you get an idea of what it looks like, what we create. These are some images from Schaijk. It's a relatively new part of Eindhoven where we have a lot of buildings that we made there and that we repurposed over there. Bakermat is finished, I think, last year. This one, quite a creative architect. There didn't have to be anything straight on that building, so it was quite and it became a landmark in Eindhoven. Even for the short period that is still there, it's already a landmark in the city. This one is next to the actual project that we're going to discuss later. So it's Bouwveld T, so project T. This is finished. I don't think it's finished yet. It's almost finished. So we have this is almost done. This is a very big. It's a very zoomed-in picture. This is a very big industrial project. It's called the Brainport Industry Campus. It hosts the crème de la crème from the manufacturing industry in Eindhoven. So it's a very nice project. This is phase 1. I don't know the numbers, but it's huge. It's gigantic, and phase 2 will be even twice as big. So there's going to be some more of this. Big customer that this is the first project we did for ASML. You might know it as the biggest company in the Netherlands, I think, almost. They create chip machines. So the chip machine, not chips themselves, but the chip machines, and they're a huge, big customer for us. We're working on a new project for them too, and this one we finished in, I think, 2021, 2022 this year. This one was named after me, so it's Nico. That's a joke. Nico is, we started this year, So this is this first project that's going to be over 100 meters high that we're going to build. And we're in foundation right now, so this is pretty fresh. What's going to be, or I think one of the biggest projects for the next few years. And this one is also it's a little bit later than Nico, but it's also 100 meters high, and it's next to the football stadium, soccer stadium of PSV Eindhoven. So when you buy an apartment on the top floors, you don't need a ticket anymore for the football games. You can just.
So I guess they're a lot cheaper.
They're a lot cheaper. Yeah. Yeah, I can afford them, I guess. And then the project we're going to talk about, what it's today all about, is Project S1. That's the working title. It's known as 65. I thought it was on the internet site as 65. So these two names are going one way to the other. But it's the same project, and it's kind of an average project that we built. I think it's 65 or 70 meters high. Approximately out of the 11,000 square meters, it contains 105 apartments. It's designed in 2018, which means that most of the knowledge and the things that you're seeing in the design phase are already 4 to 5 years old. And so that's it evaluated. So it's the knowledge that we have done. And at some point, we're going to make the bridge to what happened after that. So we're going to show you some newer things from newer projects. Also, so we're going to make some bridges to what happens right now in the company. Engineered and built 2019-2020. 15 BIM companies involved, so there were 15 companies next to us who are creating BIM models for this project. And in total, is over 40 BIM models that are used in this project. So that's so far for introducing Stan and the coding to you. For me, if there is any questions in between, just make it interactive. So for us, that's the best thing to do, I guess. Or there should be an obstruction to do that. But
yeah,
okay,
as you wish.
Anything is not clear, please get questions.
I'll keep an eye on the chat as well for you.
Yeah, perfect. Just throw them in.
Yeah.
Okay, so then a little timeline of what we're going to see in the next next half hour probably. This is a scheme of initiation of our process, actually from initiation to actually in use, and the data set contains parts in all those phases. So we'll start by showing how we are using 3D and open data actually in the early plan development phase in order to design actually our job sites. We're going to show you how our BIM design workflow works in the design phase actually. Also in that phase we use a lot of 4D simulation tools actually to understand how we're going to build our building in the best way. So we'll show that as well. We show a little bit about how we work together with our subcontractors. We show you how our subcontractors then will use the data for their production methods actually. We did a really nice experimental project called BIM-based track and trace on this specific project for the prefab facade. So we'll show a promotional movie of that one as well. We have a concept called dynamic job site where our superintendents actually are designing job sites on a daily basis and adapting them to the situation on site. We're going to show you that, and we'll finish in how we make our data queryable and searchable in the maintenance phase. So that's where we end with times in terms of examples. But this is what you can expect in the next few minutes. So starting with the initiation phase, and I will go to a live demo in a few seconds. So when a project starts in our company, we actually scrape the internet and scrape all the data sources which are available in order to know what's exactly on the site we're going to build on. So usually when there's a plot, we want to know everything about the environment in order to prepare for that specific environment. In the Netherlands, we have quite a lot of public data sources which actually describe that specific place in the environment. So we have cadastral information. We have 3D point clouds of the Netherlands. We have 3D data sets of all the buildings which in there. What we actually do is we get this information to our end users, because at this moment it's difficult for those people is they know that this data is all available, but it's all on different places, on different data sources. So for them it's difficult to collect them. So what we developed is a thing we call the Volkswagen Map service, where we actually scrape all those information and put it in a usable format so that then you can use it. And that's what I'm going to show you now. So what we actually do is that this is our CDE, so our common data environment is called Trimble Connect, where every one of the project can log into. And we made a service where we actually select the place in on the map, we scrape all the data, and we put it together in this folder, so everyone can look at it. Not only our project team, our internal project team, but also our partners like architects, structural engineers, etc. Here you see all the files which are actually the raw files, but we combine them together in, for example, a SketchUp model. So the raw data is the open data, but people cannot work with that actually. So we combine that, in this case, in a SketchUp model, which can be viewed then in Trimble Connect, is where you can see it right now, but they can download it, they use it in SketchUp. But we also make it publicly, we make it also available in a Revit file. So depending on how you want to use it. And this is actually the environmental model of the project we're going to work with. So this is the plot where the S1 project arm is located, and all the environmental things which were available in the data are shown here. So all the other buildings which were already there are shown here. And below here, all the raw data is shown. You can select it, you can filter it, but this is the basis actually for our project, and also the basis for a lot of things we do in the project. So this starting in 3D is an important thing for us to do, and also making it accessible for the single users. It's a thing we managed to do. So if you then look at how we use it as a contractor, because we give this to the architects as well, and they use this for their own like renderings and placing the building in the good environment. But as a contractor, we use it as follows. We actually import that model in SketchUp, and our job site engineers in a very early phase will design some very basic stuff in there. So we import it. This is the building next to it. And what we teach them to do, it's not high tech, it's just placing the crane on the good place, modeling some very basic fences, modeling some trucks in order to be able to show how the trucks will drive through the streets while building. And they also model the safety zone for crane lifting. So in Netherlands, there's an important law that says if you lift things with your crane, there must be a safe zone for all the people working there, but also for the people who live there in the neighborhood and not working on the job site. And always when we are in conversation with those governments, trying to get the project permitted, we always had those discussions about, okay, where are the safety zones? And these discussions were always 3D discussions actually, because safety zones are changing when the building is getting higher. So doing those discussions in 2D was really hard to do. And now we just make a simple SketchUp model. We model the safety zone, and then the government says, okay, looks like you thought about it. It's clear immediately, so let's get that permit. So very simple things, but we give those tools to, yes, there's a question.
Yeah, do you use this 3D model for that submission to the government?
Yeah, and actually we train our people just to open SketchUp and go with the laptop to the government, say this is it. That's the most used thing. Sometimes they just make screenshots and then they give it, and then it's also clear, but it's as simple as that. Yeah. So they do not need other software or presentation things. It's just bringing the data and saying, okay, this is how it works. Another thing which we do with the environmental model is actually combining other projects. So this is the area we're developing a lot with our company. So all the buildings you see right here are BIM models from other projects actually, which we combine in one presentation mode actually, which we then use. Let me. Which we then use just to talk about it with other people. It's not a high resolution rendering engine, it's just Enscape. I'm not sure if you're familiar with it, but it's a plug and play tool which is live rendering, and that just works for our people to get them talking. So these are also things which our project managers, project developers can bring them themselves. They just click and it works. They show this in their conversations actually.
To add something to that, we don't model anything in it, so we just combine things we already have. So it's as easy as that. Just put it on the right place, take the random model, and this is the result.
Okay.
Yeah.
I think I'm giving back to Niek to talk more about the design phase of our.
Yes. Thank you, Stijn. So now we move from the initiation phase to the design phase. So it's really another phase, and I think in BIM terms, design phase is the most important phase that you have in this part. It's mainly the basics for every other thing you're gonna do after that. So you create a lot of data, a lot of models in that phase that you're gonna use and reuse in the project later on. But first I want to talk about openBIM, and I'm very aware of that I'm in the place where only openBIM minded people are, but it's critical that you know to tell to other people why they should use openBIM, and that's what this slide is about. And so I don't have to convince you to use openBIM, I guess, so otherwise you wouldn't be here. So that's not the goal that I have, but there are 5 important reasons why we should use openBIM and tell other people why we should use openBIM. So that makes sense. And the first one is obvious. It's we want to collaborate with everyone, and we want everybody to be able to choose the tool that they want to use, the tool that fits best for their internal process. We want our data to be future-proof. We still want to be able to access our data in maybe 5 or 10 or 20 or 50 years. So I don't know if I open a 2018 Revit model in 2040, if that's going to work. But I know for sure, if I have the IFC, that there is a tool, or I can create a tool that I can open that data with. So to be sure that we don't lose the data, that we have to choose for openBIM. Legal separation, so because we work with aspect models and everybody is responsible for their own aspect model, that's an important reason to work with openBIM. And the last one is integration with other processes and other systems. So what we can use the data to reuse it in like a planning tool, or like a calculation, a cost estimation tool, so we can reuse that data.
Maybe need to add a little bit. Those principles are taught by everyone in our company. So if you join Volker Wessels, or you join Volker Wessels Construction Real Estate Division, you get an introduction course in fundamentals of BIM, the basics of BIM, and those principles are just things we explain to everyone from CEO to superintendent. It's important that everyone is aware about just those principles.
About the why we should do that, so they can tell other people why we should do that and why we make that choice. Next one, I want to ask you, what is by far the most important part of BIM? Who dares? The information. It's important, but it's not what I mean with it. Collaboration, yeah. Who was that? Washing machine. People. So yeah, these guys are the real heroes. These guys are the ones who do the work. We just teach them to do things, but these guys are the ones who do the work, who really know how to get to do the project, to communicate with all our partners, who get the right data, get the right models. So by far, the most important part of BIM is people, and to educate these people and to guide these people in their daily work. Because if you can educate something, but if they have a question and you're not there to answer the question, it's not going to work. So, like Stijn already mentioned, for the last 7 years, our main job was to educate and to guide the people to do the work. Otherwise, it's never possible to do all your projects in BIM. If you have to do everything yourself, it isn't going to work. So you got to educate, you got to spread the word and let other people work with openBIM. Then some practical things we did. You might recognize the sheet from the presentation that Stijn and Jan gave on the main stage last Tuesday. But this is the heart of how it works. And well, again, I don't think that is new for you, but it's how it works. Just how we organize all our projects. So it's important to tell. All these people, all these parties, they all model, and they model in their own tool. And we don't care what tool it is. Just choose the tool, whatever you like, as long as you can create an IFC that we can use. And so openBIM means this to us. And as a main contractor, and that's an important thing. As a main contractor, we gather all these different IFC models, and we put them together in a coordination model. And this is the clue to do it as a contractor, because if there's something wrong, at the end we have the problem as a contractor, not the architect, not structural engineer, not the MEP. We've got the problem because in our process it doesn't fit. And when the crane comes and puts the wall in place and it doesn't fit, it's our problem. So this is our vision, that we do this process. We take these models and we do the coordination. And how do we do the coordination? Of course, we coordinate on the combined level, and then we make issues. We get later on how that works in time, and we use DCF to communicate those issues back to the modeling parties. Nothing fancy, nothing new, but this is how it works. This is how we do it. Another thing, also nothing new, but you can use IFC's interoperability between the different software packages and use the IFC of another party as a reference. So this is how we do that. Then something in time. So how does the design cycle? How does that work? The first thing we always do. It's BIM kickoff. Maybe BIM kickoff isn't even a good name. Maybe it should be a project kickoff. It's an important meeting where you gather all your parties that model for you, and you're defining principles. You're making agreements about BIM, but not only about BIM. You're making agreements about technical solutions. You're making agreements about planning. You're making agreements about all things that you need to be able to get the project going and to get an efficient process in creating the virtual model, and after that the real model, the real building. To make these BIM part of the agreements, we have some helpful documents. I'll get on that a little bit later. So this is BIM basic IDS, the Dutch one. And when you've made all these agreements, then you're finally good to start modeling. And so you're starting to model, but there is some tips that I want to give you to be sure that you do this efficient. And there are two very important things that you have to keep in mind when you're doing this. The first one is, don't model the whole building at once. Don't do it, because you model the whole building. I have to check a whole building. The modeler has to adapt the whole building. Everybody has a lot of work. So the trick to do this is choose your batches. Work from small to bigger to large to a whole building. Because if you, for the S1 project, for example, we started with one apartment only, and we checked that until that's right, and then the principles that were in that one apartment, we put on a whole floor. And when we checked the whole floor, including the elevator and stairs and all that stuff, we went to the whole building. So think about how you do that efficiently, so you don't have to do any rework that's not necessary. So that's the first step when you initiating this design cycle.
But it's only for the high rise.
No, it works for every building. Yeah. You can do this for every just for houses, or just choose a part, get that done, and get all the things out, and then move on to the next one.
You have to make also some main transport pipe and ducts.
Yeah. Maybe also to emphasize that you have a technical thing where we're really focusing also on the BIM parts. So if you just start with one wall, maybe one window, you can really check, are all my BIM principles correctly adopted? So do I have the good elevation? Do I have the good classification? Is my material system good? So if you do that just on one object, you can already give the feedback, and then start doing a more complex object. Doesn't mean that the actual designers cannot think about the technical things in the building, of course. But in the BIM cycle, it's about starting very
the big clue is modeling things first time right. That's just as much as possible first time right. That's the idea. The other tip I want to give you is don't make 2D drawings every week. Don't do it. Just work with models. So you can do all your whole job with models, and you don't need these drawings. You need these drawings at the end, but not during the phase, because it's a lot of work for the modeler to create these drawings every week. So don't hesitate. Just work with the models, get everything out, every problem out, and then go on. So two important things, and now we can get going. And now we can get model things, and we can make an IFC export. And this one is also a very important one. Ask the modeler to check their own IFC. I can't count the times that I got an IFC with nothing in it. Just because you don't get an empty sheet of a drawing, but you do get an empty model. Just because they push on the button and mail it, and that's it. And so ask them to check their own IFC. Very important. Don't throw it over the fence like these guys. Then upload it to the CDE. In our case, mainly Trimble Connect, but you can use any CDE that you're convenient with. Doesn't matter for this process. And then we're going to do the model check. So we're going to see if every agreement was done well in the models, if it fits together, if everything is okay. And then there's a moment that says, is it complete or isn't it complete? Well, obviously, if you're not in the final batch, it can never be complete. And so the first few cycles are going to happen anyway. And so if it's not complete, then you need to do your coordination session. You get all your stakeholders in a room, preferably. Teams is also a nice alternative, but I prefer the physical attendance, but it can be a thing with distance traveling and stuff. So the coordination session, and in the coordination session, you talk about all the issues you found in the model. And if there are too many issues, then your batch is too big. Then your chosen batch is too big. You have to go through all the issues that you found, and if that's too much, then you've chosen too big of a batch. Next thing, when you finish your coordination session, you can process the issues. So people gotta maybe get to some other meetings or get together and process the issues and find solutions for the problems that you found in the BIM model. What's also very effective is to let the modelers work together on site. So after the coordination session, just leave them in the same room and get their laptops open, and they can adjust their models and talk about the models, and it's a very effective thing to organize. So get them together, and then the whole thing starts all over again. So again, you start modeling, so that goes around, and you have to make a choice. How much time do you need for this cycle? Mostly it's a weekly cycle or a bi-weekly cycle. So make a choice to do the weekly or the bi-weekly cycle. But longer isn't effective, but then there's going to be too much modeling, too much checking. So keep it or weekly or bi-weekly in this. Now then, you have the modeling going on and on and on and on. You have a complete building. So your design models, so your architect, structural engineering model, and MEP model are finished. And that's the moment that you're going to create the output, not earlier. So then you're going to create the output. You're going to create your drawings. You're going to create your ITOs for cost estimation. You can create detailing. You can create anything you want from the model, because now you know that your model is correct. And that's the basics for all the things that come after. So you check your model, final model, and then create the output out of the model. Yes?
Do you get any of the construction staff involved in the design phase to do the assessment, design, application?
Is that very...
Do you get some construction staff involved
Yeah.
in order to do buildability assessments
Yeah.
and design for manufacturing assembly?
If it's a difficult part that we don't know ourselves how to create it, yes, of course, yes, we get our manufacturers involved, and just for advice, just to know how we do certain things.
Also, in a few slides, we're going to show you how those people are actually involved in the planning process and in a very early stage.
As I promised, this document, it's the BIM basic information delivery specification. It's actually just a human readable one, so not the XML things. So it's just human readable, and it's no more than these two sheets, and that's what makes it so powerful. And it's only these two sheets. It's BIM basic IDM, and everyone who's involved in BIM in the Netherlands knows the BIM basic IDM, knows these two sheets. And it's about some very simple agreements. It's about make agreements about your file name. What file name do you use to share your models? And make agreements about the local position. So not one model is over there, one model is over there. And make agreements about building stories. And make agreements about clashes. What clashes do you accept in your process? What clashes do you not accept in your process? All these obvious things, but it's kind of a guideline for your BIM agreements, and it works like a charm. It's as simple as that. And I guess this is the English one. I think it's available in many languages. I don't know how many, but I've seen Chinese one, I've seen Italian ones, I've seen all kind of translations of this part. And they're all available. And this one we include in the data set. Maybe we can include.
Yeah, we actually included the full BIM kickoff, including all the requirements of the project as well. And this is one part of the requirement list.
Yeah, but we could add the translations of this also.
They can find that in BIM.
Oh, we can use the link.
To emphasize a bit more, also these fundamentals are educated to all of people in the company. So when you come in the BIM basic course, they know about the existence of this document, and they know where to find more information about it. So this is also one of the fundamentals of teaching everyone in your company.
Yes. So BIM basic IDS, it's gold. It's great. Then this scheme pops up. It's our design and engineering cycle. You might recognize it from some earlier presentations done on the buildingSMART summit. This model was, I think, was presented in 2018 by Jeffrey and Manomakis for the awards. They call it the hamburger. I think ours is more like a pancake. but or is it more like a pancake? But it's got exactly the same goal. So what it says on the top side, you have your design models. So that's the cycle which we just saw with our architectural or structural and our MEP models. And in these models, we determine what we're going to make, how it's going to look like. This model is always first. The fourth one is here if there is an important fourth party or fifth party, and maybe your answer it can be done. We've done projects which we have with like a facade manufacturer that joins in to add his model immediately to the design models. But most of the time it's just these three. And the design models are the basics for the engineering. So in the engineering phase, our suppliers get involved, our subcontractors get involved. So maybe our MEP contractors are involved. And they also create models, but they create models based on the principles that are made in the design model. And it looks something like this. You have this is a typical design model with the placeholder objects, and they're filled in by the engineering parties, filled in by engineering models. So that's the below side. And I'm going to show you in a minute how that works in a live demo. So this is another example. So you see a big difference in detail level between these two models. So, but they're both valuable, and the funny thing is you don't exchange one for another. You just put them together and see if it fits. Different models between below this one, and I'm going to show you the structural model. I'm going to make a section at some place and show you to combine this one with MEP models. And just pop up. Let me just take this one out. It makes it a lot clearer. And this is the job that our early engineers do. They just check if everything fits in, if the MEP parts fit within the structural parts, and then they combine it with the architectural parts. And this is the final model that came from the cycle that I just told you about. This is the final combined model that we use in all other processes. So it's really built from the different models, and it's never 100% good, never 100% correct, but it's close enough to do our work with it. So that's maybe 95%, but that's fine for us. So that's what it looks like. Sorry?
Leon sent me the links to them.
Okay. The next thing I want to talk about is the issue management. The BCF part I mentioned before. So we used the BCF files to communicate from the central model, from the combined model, to the modeling parties. But funny thing is, the BCF also makes it possible to communicate back. So you can get your remark and your redlining from your central model to the modeling parties, and they can adjust their models in the native software, create a new ISC, and then that circle is run. But they also, if something is not the way you expect it to be, they can also give a comment and give back why something maybe isn't adjusted, or why something isn't done the way that we expect. And this works, but it's quite an intensive workflow. It's quite hard to keep up if you have many parties and you have all these BCF files that are shared, and you have to load them and to put them over the right place. So it's kind of a lot of work to get this going. But in the time that we coordinated as one, we did it this way. This was how it was done. Fortunately, now we do this differently. Oh, first I have to show you how that looks like in real. So these are issues. So this is an issue that has some communication in it. So you see here, the first issue was that there has to be a hole in the wall that wasn't there before. And this is the communication from the MEP engineer, from my colleague again, and then again the MEP engineer. So the circle is round, so we know what happened, why it happened, and we've saved that in based on the models that we use. So there's never a discussion why this happened and how it was done. But as I already mentioned, it's quite a struggle to get all these IOC files and all these BCF files and get them at the right position in the software. Unfortunately, there were some software company that also saw that problem. And this is, I think there are more, I don't know any, but I think there are more companies who do that, but they created a BCF platform. And that's a great thing, because that helps a lot to get the BCFs, get the remarks at the right position. And so they position all issues in a central platform, a central database. And what you can do from all these different software packages, you can synchronize to that server and just get your issues. And the result is you're always up to date. You're always up to date with the late issues. You're always up to date with the questions, with the answers, everything that's happening in your project. It works like this. So this is not for S1, but this is the way we do this right now. So we use the BIM Collab server to do this. Another subject that we're gonna talk about is the 4D planning. 4D planning, putting the things in time. So the 4-dimension is the time. And at the time that we prepared S1, this was pretty new. This was very innovative and not very advanced. But it gives nice views, gives nice things. But the value isn't so big, because we know that this is going to be the way to build this. But it gives some insight, and we did some things with 4D in this, but we didn't really get value of it. We didn't really solve anything at that time. And this is a technique that evaluated in time, and that we made better and better and better, and that we use now in our project to really build virtually. And to be able to really build virtually, you need more than just the models that you get from your partners. You need more than an architectural model. You need more than a structural model. You need more than your MEP model. You need all the objects that you also need to build it on site. You need to have them virtually, and that's the clue. So what you see here is a more recent 4D planning, which has all the equipment that we use in the building side, modeled and put in time, and then we know what to expect, and we know that in this position there can be anything else at the time. So when you show this to a superintendent, he says, "Oh, but that's not going to go right, and that's wrong, and there's going to be a problem." And they start thinking about it when they see this, and that's the big advantage with the 4D planning as we do it right now. We can really simulate what's happening on the job site.
So this thing is done not for the whole building, it's just done for specific batches, specific critical parts or technical parts which are iconic for that specific building. So in this case, we just do one elevation, run through all this elevation with our construction guys, with our superintendents, with our project managers, with maybe some specialists which deliver the scaffolding, for example. So just about optimizing that specific workflow in the early design phase, and in a lot of cases it also reflects back to the architectural design or structural design to optimize some things there as well.
Yeah. So and the nice thing, you have to create these objects, but sorry.
There was a question online, which tool you use for issue management?
The BIM color. Yeah, BIM color. Yeah.
Can I follow up to a question that Robin asked earlier? Are you seeing that you're getting the opportunity to engage with the specialist manufacturers who do off-site and be information? Because quite often what happens in traditional projects is they don't get engaged until later on, and all the opportunity to use their innovation and their the improvements to productivity that their solutions will bring. They don't get engaged until too late, and therefore the opportunity is lost. Are you seeing on real projects these people being able to engage earlier and their solutions being worked into your designs because you're using openBIM?
Yeah. I think I understand you. We do get these parties that make these difficult parts of the building involved earlier, and sometimes they just do it because they know that we give them they will make the work anyway. But it's also possible to just give an engineering assignment to that party. So just start with engineering, and then afterwards we can still see if we're gonna give the work to you or to another one or so.
Yeah.
So is that what you're?
Yeah, I mean, it's quite often the innovative people that make productivity better, they're not engaged until too late.
No. Of course, if we don't know that they exist, then we can't do it. But if we know that there's somebody with some specialist knowledge about a certain part, then we ask them to advise us, or even to be one of the modeling parties that's added to the design cycle. So that can both be
Because yes, we already try to involve those parties by using the BIM models. It's in a few minutes it's clear what the challenge is actually. So they can better communicate with us. In a lot of cases, they then say, okay, can we be part of this BIM model as well? How can we do that? Maybe one example that's perfect bridge to actually this slide is one example is we first modeled those. These are elevators on the job site. We used to model them ourselves on our job site, and we talked with those elevator companies. Actually, okay, this is your elevators. Is this my elevator? Yeah, we put it in model. And after those conversations, they actually said, okay, can we deliver you our models ourselves so you can use those models in the design process? So those companies are really inspired by such examples. But if they're not willing to do that, we all in them ourselves as well.
I think you're saying that actually you're so advanced in the way you do things. The question I'm asking is just obvious to you. It's not necessarily obvious.
You mentioned that you say take a single floor and do all the report for the site. When as your building gets taller, then the cranes on to lift the container subject floor increases. When do you bring in some of the logistic issues about as your building gets taller?
Yeah, that's a good question, because if you're making a detail for the planning, that is an issue if you get higher. And so what we do, and it has something to do with the track and trace part we're going to show later, because track and trace measure the time that it took from the things on the ground, but that's later. But we do take these times and make mostly it's just like a percentage which it takes longer, and put that in for the plan. Yeah, so, we do that. Yeah. All right. So much for the design phase.
A little bit back on this slide back, because it's important to emphasize that a lot of the objects you saw in the 4D scheduling is we make them ourselves. So these are contractual or main contractor models, which do not have a high level of geometry, not have a high level of information, but they're just made by people working in very early stages at ourselves. So we help them as BIM managers with training them how to set up a proper library, so that in projects they can just use those models. I mean, we used to do that in we do that in SketchUp, and that's working perfectly fine. To emphasize it, it's made by people in the projects themselves, not by the BIM managers or specialists. It's put in the hands of the BIM.
Okay. Next phase, engineering. So we move from the design to the engineering. So the real team that's going to do the final engineering of the project comes in. And then we also move from this part of the engineering cycle to that part of the engineering cycle. So now our suppliers come into the process. Now our subcontractors come into the process, and they're going to create models, and they're going to create the models based on the design models that we made. And that process is exactly the same as the design process. So I'm not going to explain that again. The only difference is that you have your design models as an input in the process, but further on the whole cycle with the modeling, IFC export, checking their own models, it's all exactly the same. So I'm not going to tell you that again. What I'm going to do is going to show you what it looks like. So we're going to start off with the structural model again. So this is still the structural model from the top side of the cycle. And what I'm going to show you is the ground floor, which is actually a hollow core slab floor. And in basic, in the structural engineering model, it just looks like a flat pancake. It's just a hollow thing, a placeholder for what's gonna be modeled by the engineering parties. And if you then add the engineering part to this, so now what I'm now going to do, I'm going to combine the two models. So now you see I'm going to combine the model with the engineering model, and easy as 1, 2, 3, you can see if it fits, because you've checked that your design model is correct, and if your engineering model fits within the design model, then the circle is round, and you can do that. So it's a visual check. There are some helpful things in the software to do things automatically, so it's like a helpful thing, but it's mainly a visible things fit in it, and you can now see the difference in detail level between the two ones. So this is not a flat pancake; it's just a filled model. That's one example that I wanted to show you. Go back to the structural model. Put the next one in the context, because the next one I want to show you is the facade anchorage. So there's a very detailed model in here for the facade anchorage, and that looks very detailed, last screw, the last millimeter, what we're going to get. And the task that our engineers had is to make this fit on the prefab concrete model. So in the prefab concrete model, there are I don't know the English word, excuse me, but sorry, bolt slots. Yeah, so and that has to fit with this one, and I hope it does. So now to show you, I'll make a. So you just see the bolt right now over here. So the bolt is in the prefab concrete, but that's because this is the model from the structural engineer, so top side. And when I put on the model from our subcontractor, you see that it actually fits to the last millimeter. And this kind of thing, this makes me enthusiastic. Like, this is the best thing in BIM. I'm an engineer, so I like these kind of things to make this fit. So that's nice. And this is mainly how we do it in engineering phase for all the different suppliers, for all the different subcontractors. Just check visually and use the tools that we have to make it fit, because that's what we do. We put a building together, and it has to fit virtually before we know that it can fit on the job site. So that's our biggest thing.
Yeah. Let's take the next example. So the next example we're going to show you actually is a typical thing of what's happening in this engineering phase. Is that not everything is modeled by our partners. So you have some smaller companies, some very specialized companies which do a really small part in our project. But sometimes those parts can be critical for us to actually also have them in the model. So those parts, this is one of those examples. So for our project, which was high, like 70 meters high. If you have scaffolding high like that, you need to anchor it to the construction, because otherwise your scaffolding will collapse or fall. So therefore you have those scaffolding anchors, and within those anchors we always get advice from some scaffolding companies to say, okay, on this specific places you must place your anchors, but they do not model them. But because we have a prefab facade, we must know for sure that those anchors have a place through the prefab facade to actually connect them to the structural elements of the building. So those objects which fall actually in between, and we train our people actually to include or to model those anchors themselves. So what we're going to show you is that they use the advisory, the DWGs from the consultants. They place that on the right place in the model. They just model a very simple anchor, just a cone of 30 centimeters themselves. So within SketchUp, I can teach everyone within 5 minutes how you must do that. So it's a super easy job. And then they export that to IFC, communicated that with the prefab facade engineer, and he could actually adopt those in his model and make sure there was a little hole in the facade so we could anchor it on the place. Let me show you how that looks like in practice. So the one who was preparing this in the project, he actually gained some DWGs from the specialist with some advice on where those anchors must be placed. He placed them in SketchUp on the right place together with the prefab facade model at that moment. So that was still a conceptual first draft of the facade, as you can see right here. He modeled just those simple cones within a few hours actually. And why this is also a critical part is because there's not one or two of those anchors in the facade. There are hundreds of anchors in the facade. And if we miss one in the project, then we have to drill through the prefab elements, which are so expensive that we didn't want to risk it. So this was actually a critical part. So we placed all those cones on the right place, exported them to IFC, provided them to the project engineer, and that actually resulted in actually two models. So this one, let me go to here it is. So I opened the prefab facade from our subcontractor and just this anchoring model, and as you can see right here, there is a little hole in our prefab facade. Exactly this anchor is fit in, and while doing the construction there was no fault at all. And actually for this one, our project engineer actually used the automatic clash control in Solibri to ask, okay, is there any clashes between the anchoring and the prefab facade? Because there were like a few hundreds of those points. Walking them through each was not a thing which was good to do, so that's what he did. Just a very simple thing, but this makes it that the BIM model stays centric in the process of those people working in the field. So just as an example. Yeah. Go to the next.
Yes. So that's mainly it about engineering. A lot of similar things to the design phase. Production phase is mainly something that we don't really are involved in. It's our suppliers or subcontractors that create these things. But it is an important phase because we want to have the feeling with that phase that it goes right. And I don't know, WYSIWYG, it is an English abbreviation, you know it?
What you see is what you get.
What you see is what you get. Be sure that this is the case, because what you see in your IFC model is what you get on the job site. So make sure there is no additional steps in modeling, in maybe creating 2D drawings. Be sure that your supplier, has his own process like this, because then that's the only way to know for sure that what you get in your model is also going to be on your job site. So check this, talk with your suppliers about this. So this is an important part. And if they don't do this, then get a feeling how do they do it? Do they just make the models to make us happy? And there's a completely different engineering part which for the internal process. That's a big risk. Then you can't know for sure that these models are the same. And so always keep in touch, talk to your supplier, talk to your subcontractor if this is the case, or if he gets close to this. So that's important. And then hopefully it looks like this. So you go from your model to the real world. For the ones who weren't looking another time. Yes.
Just thinking of your painter for your scaffolding going through the precast panels, someone has to then come through and seal those footprints and hand it over in order to prevent water leakage through the facade. Do you consider the process of sealing those holes at this stage, or do you consider that later?
The explanation is to come to you.
So you've got your anchors for your scaffolding that all the way through the facade. That then has to be sealed sometime in the construction process to waterproof and everything.
Yeah.
Do you actually figure out that process now, or do you do that later?
That's the moment to do that also. You have to think about it. You have to think about what I use in that phase. The last phase is you can't think about it. Yeah, how you get that done? Yeah, just think about it. That's the engineering. Positioning is what we do.
So I have a question.
Yes?
The phases you showed us on, are those typical phases you find in all projects, or is it just specific for this type of project?
Say.
No, the phases, design,
That's every process is every step. That's just our working process. Yeah. So that's mainly all there is to say about the production phase. Just be sure that what you see is what you get. No more, no less.
Okay. How we're in time then? We still have 20 minutes. Okay, well, talking a lot, so make sure we finish in time. So when moving from production to construction, we're gonna reuse and gonna get all the benefits we had from the model actually on the job site. So we're gonna make those models to the job site, and on that moment it's actually important, or first it's important, what we focus on is that the people on the job site can access the models in a way that they will always start with the model if there's a question. So traditionally they have a large area, a large closet with all the drawings in it on the job site. And if there was a question on the job site, the first thing to do was get to the closet, take a drawing and answer the question. So first it's really important that that's changing into a situation where if there's a question, they go to the model, zoom to the correct place, and then solve the question. So for that, we have a few basic principles we try to apply on all our projects. First is, and I will show them in a minute, give the people access to the model in one click. Make it the most important part of your folder structure, of your file structure in your CDE. Just in one click, make the model available. Then the second thing is combine 2D and 3D. I will show that in the demo, then it's easier to talk about that. And the second thing is about make sure you have the details ready for those people as well. Because some things are just not modeled, are not seeable in the model, they're not in the model itself. But in practice, every single detail must be made. So we combine 3D and detailing in a way, and I will show you that in a minute. So we move to Trimble Connect. And what you can see right here, actually, let's see, there's a drawing in here, but on the left side, you see our folder structure. And the first folder you can see right there is 0.models IFC. All the models which are definitive, which are usable by the superintendent, are in this folder. So as a result, he just has to open this as a starting page every day, has it open, and when someone comes in and has a question regarding, for example, the structural part, and maybe combined with let me see what is here, the hollow core slab, which Niek showed you a few minutes ago, he just has 2 clicks and then has it available. It's maybe too simple to explain it. It's, if you don't do this and people are searching for over more than a minute to actually be here, then they run to the closet and take the drawing and don't look at the BIM model ever again. So that's the first principle we use. The second one is one which we call hybrid modeling or hybrid models. Let me open the other one. It's about combining 2D and 3D. It's about if a superintendent looks at the model, he says, okay, it's nice, but I need information out the model. I can see there's a column in here, but what kind of column is it? How large is it? Where must it be placed? In what area is it? And traditionally, all this information, all this annotation on the model is placed on the drawing. So when people say we do not need drawings anymore, at this moment we still need drawings because the information which is actually usable is hidden in the model, but placed on the drawing. So we combine a 2D and 3D model. We offer them at those people so they can look at the model and actually see, my wall is that large, or my these are the parts which are maybe not modeled, but which are actually relevant as well. So that's hybrid, a thing we call hybrid models, 2D and 3D combined. And then the last example I want to show you is to combine actually 3D detailing or details in your model. So as you can see here, I opened the architectural model, and what we did is that we indicated in the model with just a 3D text where specific details are located in a specific place of the building, because those details actually are used a lot by our superintendents and the people on site. Oh, ad block. So what I just did is we're not only indicating, okay, there it is. We're not only indicating the place of the detail, but we're also combining the physical the document which actually describes the building or the detail to that specific place. So a superintendent can go to the model, click on the detail, and is directly directed to the specific detail which is used in the construction site. So those 3 fundamentals are actually not, you must start with those things to make the model a central place at the job site, and then you can do the fancy stuff. And the next video we're going to show you is actually some fancy stuff, some experimental things we did at the job site. It's about BIM-based track and trace, and everything is explained actually in the video we're going to show you right now. So I hope it will work.
Op Strijp-S in Eindhoven werken Volker Wessels ondernemingen aan het innovatieproject Building Object Tracking and Tracing. Deze pilot richt zich op het testen van een track-and-trace systeem, waarbij 348 betonnen prefab-elementen vanuit het BIM-model digitaal worden afgeroepen.
Nou, de kracht van BOT 2 is eigenlijk dat we continu de verbinding zoeken tussen het digitale BIM-model en het fysieke prefab element. En in dit geval is de scope van het traject is eigenlijk vanaf het afroepen van de uitvoerder van de prefab elementen tot en met het hijsen en monteren en uiteindelijk het goedkeuren van deze elementen op de bouwplaats.
Het digitaal afroepen van de producten gebeurt door de aannemer. Zij kunnen in een digitaal portaal, vanuit het BIM-model, de juiste elementen bestellen voor hun project.
Als ik begin met het afroepen van de elementen, dan zie ik in het model welke elementen dat ik reeds heb afgeroepen, zodat ik ook nooit de verkeerde elementen kan afroepen. Verder kan ik de montagevolgorde aangeven, de betreffende levertijden en dan kan ik de gewichten van de elementen zien om zo een inschatting te maken of ik 1 of meerdere vrachten die dag nodig heb.
In de toekomst kan een logistiek coördinator, vanuit een bouwhub, verschillende vrachten bestemd voor meerdere projecten coördineren. Het systeem is klaar voor een optimale bouwlogistiek.
Ik krijg de afroep binnen via het systeem. Alle gegevens betreffende afmetingen, gewichten en merk van het element krijgen we uit het BIM-model. Vervolgens kunnen we dat verwerken tot de laadbon en die gaat naar de verlader.
De afgeroepen elementen worden geproduceerd. De interactie tussen aannemer en leverancier gebeurt geheel digitaal en geeft inzicht in de behoeften en mogelijkheden van beide partijen. Deze pilot zorgt voor efficiëntere transporten en leveringen. De status van de leveringen kan opgevraagd worden via track and trace. De bestelde producten arriveren op het project. De uitvoerder kan door middel van een mobiele app de ontvangen producten inchecken, op kwaliteit controleren en op hun plek laten hijsen. De kraammachinist ziet welke elementen hij aan zijn haak heeft hangen en op welke plek deze moeten komen. Bouwplaatsmedewerkers monteren het element op de juiste plek en geven aan dat de montage succesvol was. De uitvoerder controleert door middel van de mobiele app de kwaliteit van de geplaatste elementen. Na goedkeuring is het proces voltooid.
This pilot we did, I think now 4 years ago, and as a result, we're actually now developing some actual applications. The application you just saw and which was used in the pilot was a very bad kind of application. We learned a lot from this pilot, and what we actually are now, what we identify is that the most important part where a lot of things are going wrong is actually the initiation phase of the subcontractor, where he is actually ordering the objects from at the subcontractor. So that's usually an Excel-based or an email-based system. So we're actually now developing a highly advanced ordering system just to make sure ordering is going well. So all the other fancy stuff you saw in the video was also pretty interesting, and we see a lot of potential in it. But we saw that in optimizing the ordering system, that was the biggest value for us. So we're now making one of those apps actually to do BIM-based order tracking. What I personally like the most about this pilot is we involved the crane driver. So the crane driver had a small iPad in his laptop or in his seat at 70 meters high, and he could actually see which elements were in his hook, where he had to lift his elements through, how the weight was of those elements, and he really said, okay, this was for him it was really impressive to see actually that he could see where he had to go. And I said, but you know where to go, right? No, I never know. He said, I just hear from the people downside, say, okay, you have to move to the left or to the right, and then it's very difficult for him to exactly know where to go to. So this BIM model really helped him a lot, and I hope we can actually still help him in the future to make this common practice on the job site actually. Yeah.
Have you considered measuring the improve the time?
Yeah, we got some metrics on how long it took to lift, and we saw actually based on that our planning metrics were updated. Also, what we saw was that the crane driver sees the predicted weight of the element, and in a lot of cases, this predicted weight was too low actually. So we updated our the standard metrics of how much concrete or how much such a concrete element should weigh at the engineering site in Tech Live. Yeah. Another example on the job site is the dynamic job site. I will click on the screen while. What we did on this project is we trained our superintendents to engineer the job site in 3D. So what's happening on such a job site is that, and let me pause the video for a second. What's happening on such a job site is that it changes daily, right? In this project, we had 3 job sites next to each other. So 3 buildings next to each other, with 3 superintendents managing their own buildings, and 1 head of superintendents managing all the buildings. So communication about which gate was free, which gate was used, at which specific time was a really important thing in this project. So they were actually planning on doing a daily stand or daily updates about the job site and doing that all manually. We actually tried with them to automate it and make it more visible in the BIM model. So what we did with them, we made a library in SketchUp of very simple objects, and we trained to just move those objects on the right place for a specific time. They would then upload that specific model to our common data environment, which is Trimble Connect. And from there, all the superintendents could see each other's plans and could align it based on the BIM model. So that's what we call BIM-based job site management, or BIM-based dynamic job site management. And what you see right here is the workflow, how it worked actually in practice. So on the left, you see SketchUp, where one is just copying and moving a very simple crane object. He's placing that on a specific job site. So we reserve that place for a specific time to do his work actually. And after this, he's going to update this model in Trimble Connect as a connection between SketchUp and Trimble Connect. This is not done by IFC, but just by native functionality. So he's uploading the data in common data environment, and just a few seconds later, this data is available for everyone in the project. It was mostly used by our superintendents to just talk about with other people about what's the planning for today or what's the planning for this week. So it's now updating, I think. And on the right, you will see that the model now is updated and that the crane is actually placed on the place where the superintendent has basically. He then saves it in a BCF kind of thing in Trimble Connect, and then he can communicate it with all involved people. And to be honest, they actually did this for a few weeks or months, and then they knew each other so good that it wasn't necessary anymore to use this kind of workflows. It's just in the beginning of a project, when the site is new, the people are new, the equipment is new, they just use those workflows, and then afterwards, okay, but now we know each other, we know each other's habits, we know the process is going each time the same, every elevation is the same process, so we know how to do it. So after a few weeks or months, they said, okay, now it's too much administrative task for us, so we stopped doing it. So it's not that we ask them to do it all the way, it's just do it only for specific purposes. And to finalize this example is that those model views were also used by the gatekeeper. So the gatekeeper who actually, where all the trucks were arriving in the morning and all the crane drivers were arriving in the morning, he had his iPad in his at the crane or at the gate, and he opened the model for that specific day or that specific week, so we could directly manage to get the crane and the truck drivers to the right place, actually. See, that's a question.
Yes, I don't know if this is a Canadian thing, but do you guys have resistance for learning new technologies on site versus using them only in the office?
How do you mean resistance?
Like you have to train people to go into 3D models instead of using drawings or talking to whoever's in charge.
That's the most difficult part. You have to involve them in all the conversations, and when we start with we think that this is possible.
Yeah.
The first thing we ask is, do you want to work with it, and so we go to the gatekeeper and we go to the superintendent and ask, okay,
So
how can we, and they're definitely willing. So the gatekeepers, they are so impressed by doing this, like the crane driver as well. They're open to, and the craftsmen on the job site as well, but it must be practical and not that theoretical and just one button approach. So, but everyone, most people are getting really enthusiastic, especially when they see other colleges like this oil, I mean that, how you say that. So as one people is using, or a few people are using it, they see it from each other, and then everyone will do it.
So it's a Canadian thing.
Yes, it's like
Sum it up.
I know resistance isn't only Canadian.
But isn't it also very important to listen to the ideas of the gatekeeper?
Yeah, for sure.
And they get more involved.
I see we're heading out of time, so I'm not sure. We need, I think, 3 more minutes to finish the presentation, and afterwards we can have more. So one of the last things I want to show is that it's not really a BIM thing, but we have in our cranes, we have specific cameras in the horizontal part of the crane. I'm not sure what's the English, the truss of the crane, but where specific cameras are hanging while the crane is moving over the job site. It's scanning the job site, it's uploading the images. The images are combined on a platform which is Pix4D, which we use for that. And at that moment, our superintendents can have a semi-live view on the job site, which is a few centimeters accurate. At that moment, they can overlay the drawings, so not BIM models, but just the drawings, and they can see the differences and can immediately come in action if there are any differences. Also in this case, especially in the first elevations and the first stories, it's really important to use it, because then things can go wrong. But if you come higher in the building, everyone knows what to do, and then the risk is not that high. This sample you see right here is not from the project we are publishing. We have some licensing issues, so we could not log into the data for this specific session, but we will be sure that all the data of this crane camera will be in the data set as well. For, I can imagine you could connect this to a BIM workflow to automated clash detection between the field and the models. So I hope some students or some smart people will be able to experiment with the data set and maybe find solutions to automate those kind of things.
It's not only the pictures, it's also the point clouds.
Yeah, so what's also happening, we use the pictures the most. From this data, we also gain on a daily basis 2 point clouds, which are made by photogrammetry technology, so they're accurate but not millimeter accurate. And those point clouds can be used to check with your BIM models. But to be honest, people who want to see the details prefer the photos. The point cloud is beautiful from the distance, but if you go into the details, you cannot see anything because those pixels are usually not that detailed. But this is also in the data set, so I hope people can use it for their purposes. So go to the last phase, which actually makes a cycle finish. It's about making the data accessible during the asset management phase. When the project is finished, for us it's important that if there are compliance or things which are wrong with the project, that also those people working in the asset management phase are heading to the model first, to the digital information first, instead of stepping in a van, driving towards the building, and they're searching for the right solution, because that's the current workflow mostly. Is there's maybe a leakage or a window is broken. The first thing they do is go to the site and then try to find the solution. But we have all the information in the model, we have all the information in our system, so we need to make it accessible for those people as well. And that's what we do with a platform we call Volker Search. It's in demo right now, so it's we cannot show it live, but what we do with this is we have a map with all our Volker projects. We use the BIM models as a reference in this project. So people in the asset management phase, they get a call and maybe something is wrong. They go to Volker Search, they search in a few seconds for the right project. They click on the project and they're connected to the database of that specific project with all the specific tools which were used on that specific project. So in this case, you can see that there's a direct link between Volker Search and Trimble Connect. And also here we have the one bit, the one or two click approach, but just in a few clicks, those users can immediately see all the BIM models, all the data which is actually used or needed to figure out where the problem could maybe be. This is just one of the developments which we have started actually last few years. It's all about reusing the data in all parts of our process.
How many projects do you have in the system, in the estimation system?
Yeah, in the young.
It's linked to our project portal, so without
a few thousand actually.
A few thousand.
Yeah.
Yeah. Can you say that in the microphone again?
A few thousand. we make 600 projects a year, and we're now using Trimble Connect for 7 years. So 7 years of projects stored in a common data environment will be accessible via this.
Also, funny thing about this, we don't add anything to BIM research. We just read other sources. So it doesn't not much work to fill it. It just goes automatically.
Wasn't easy to get that far.
And this is actually the final slide. It's the data set is published a few weeks ago already by Leon on GitHub. You can exit right here. We will be sure that all the social media will be spammed with the link to this data set as well. So I'm sure you will find it.
So it might be we might add some things later on, but it's all going to be the same link. So it might be a little bit more in the next week, few weeks. That we just gather some more information that we can put in.
Okay, that's it. Thanks for your attention.
Great, thank you both. Any final quick questions? Over here was first. Yeah.
I have a question about the construction phase. Do you use any kind of system to track issues that arise on site? Like, for example, you use a lot of the precast concrete, but let's say you do casting for the concrete and you have issues with the pour and you have to do repairs or any kind of issues that arise on site, and you track those and you this problem.
Yes, we have a system for that. For now, that's still a separate system from the BIM workflow. We're testing with the next step in Trimble. It's on project side, and that's integrated in project side too. So we're not the tool we have right now is a separate tool, but we do that on but it's going to be integrated in Trimble, or so in our workflow or BIM workflow. I think somewhere next year.
Yeah.
Yeah, no, I was just wondering about tonight is an awards dinner, right? So I guess you're going to win in all categories. Why didn't you submit for buildingSMART awards?
By the year, I'm not sure. We don't know it exists. Maybe.
Maybe next time.
Maybe for us this is daily practice. We don't see it as special, so I think that's my question earlier.
That's the answer I wanted. It's boring for you.
Because this is it's not unique. We do this in every project, not within track and trace, but like 6 process steps are common on every project. We do every project almost the same.
And this was 3 years ago, so you're doing even more cool stuff today now? Yeah. Good. Yeah.
So it sounds like you made the decision 7 years ago to go with Trimble. Were you part of the decisions about like what software to choose for a common data environment back then, or why Trimble?
We had like a period where we didn't know what platform to choose. So we had a few platforms that came by, and finally there were all kind of reasons to choose Trimble as a platform. So I must say I'm still happy with it. I don't have used many other platforms. It does the job pretty decently. There's always some things you can criticize, but
right. And the inputs most often are ICF files. That was coming in from, could be a Revit file that exports to ICF, or it could be Tekla that exports to ICF, and just goes through Trimble.
And the thing that Trimble is very good at, in my opinion, is to view all those IC files. Just very fast on your browser, on your local app, on your mobile app. And that works, and that's what we need to be able to give it to the superintendent, to bring it to the job site. Because if they use it once and it doesn't work, then they go back to the drawing.
Yeah, well, I think that's one thing that's nice with it is you can overlay the 2D, and the people who are used to 2D, they can see 2D in 3D environment, probably a little bit more comfortable.
The guys with the biggest hands against most enthusiasts of that part, right? The hybrid part.
Right.
It's really great to see. Yeah.
But maybe it's good at the process for choosing a platform like that, but there's always a selection of people from across all the companies that sit together and choose together. And it's not someone that's saying from top down, you have to do this.
No, it's an extensive software selection project, which I think our common data environment was 7 years ago the first. Within those 7 years, we had a few more for specific other topics as well. That's actually a thing we guide with Digibase. We get all the test and key users together in a room, try to help them in making their specifications, what they expect from a specific tool or CD. And 7 years ago, we have chosen for Trimble Connect, but it's actually every 2 or 3 years it's evaluated. It's not a. It's always we think always about, okay, that's also part of the software selection. It's can we change at a certain point, because if we now have so much project in it, we do not want to have a vendor lock-in. So part of our strategy is, and that's perfectly possible with Trimble Connect, that we can move on a certain moment to another platform without any troubles in the fundamental parts, which are the data actually.
Okay, all right. Thank you very much, everyone. Thank you, Niek. Thank you, Stijn. Thank you to all our online attendees. I'll bring this session to a close now. Thank you.